Here's number 12 and on the practice test for physics linear motion test. I assume that you can read the questions, so I'm not going to read them out to you. You can hit pause when we get to the problem if you need to. What I mean here is if you want to know the velocity, and this is time, let's say, then what you can do is at the point of your choosing, say I chose this point, you can take a tangent line that just ticks the edge of that curve, and you can find the curve of that line, the slope of that line, by taking a tangent line and finding the slope of the tangent as a substitute for finding the actual slope of a curve, which is a real booger, and I think it takes calculus, and I don't remember how. So the other way to do it is to take a flat line that lays right on top of that little tiny bit of the curve right there, and you can find the slope of that. And then you found effectively the slope of the curve at that point, and you found the velocity at that moment, or whatever the y-axis is. The distance grew greater, and then the distance didn't change for a while, and then the distance from the origin decreased as he went back to the beginning. If we include all velocities as positive, okay, I realize that he went back to the origin, and some people might argue that that is negative. And the weird thing about the physics class is that you can have arguments about whether something is positive or negative. And my example was, I think I was talking to Ramir. Ramir jumps off the desk. How far does he fall? And somebody says 3 feet. Okay. 3 feet positive or negative? And you can have an argument. Well, it's just 3 feet. Yeah, but it went downward. So is it negative? It depends on your point of view. So I'm counting all directions as positive at this point. So his velocity increased, and then he stopped, right? So he came to a pretty quick halt, and his velocity for a while in the middle was 0. And then it increased, and then he came to a stop again. So it decreased real quick, I assume, and it went back to 0 as he arrived back at the origin point. How is your velocity changing even as you're sitting around? The Earth is rotating, the Earth is orbiting the Sun, and the whole solar system is rotating in the galaxy. After that, I don't think we can be too sure, because we know those are happening because we know where the center of those things is, don't we? We can say, yes, there is a center of the Earth and a center of the Sun and a center of the galaxy. We cannot say for sure there is a center of the universe because we don't know really where to look. And apparently everything is going away from us. All the superclusters are going away from us. And so it is argued, so to speak, that if you were in a different supercluster, you would assume that you were in the center. So where is the center is unknowable, and maybe there isn't an exact center in the truest sense. But these 3 things we can say. Remember, v is velocity. This is wrong. That's supposed to be velocity, huh? Whoops. I need to go back and change my answer. Velocity is distances over time, like miles per hour, right? But it's a distance over time, or maybe it's meters per second. Often in this class, meters per second is most useful most of the time. So this is distance equals velocity initial, or initial velocity, let's not argue about that, plus 1/2 of acceleration times time squared. You have to square whatever the t value is. When it says v in the other version, it means final velocity. The final velocity that you get to is whatever you started with, initial velocity, plus your acceleration times the time that you used your acceleration. The distance that you go is 1/2 of your acceleration times the time squared. You take the value of the time and you square it, and then you multiply times the acceleration. And when it says v, they mean v final. Your velocity is your acceleration times your time. So I left this box in here because I think it's a really good reference point. I wish I'd started with this years ago. What do we know? That's the first place to start. What do we know? Let's label everything. An apple falls from a building. Okay, it's accelerating due to gravity, isn't it? So you can put A or you can put G. It might remind you of what value to use if you put G, and we're supposed to know what G is. I guess you could ask, but it comes up a lot. Let's memorize that, huh? Oh, seconds plural. Anyway, here's the time it took. And how fast is it going at the end, right? When it hits the ground would be VF. So I need a formula that uses A, or we're going to put in G. That's the same thing, acceleration due to gravity. And T and VF, and of course it's that one. And then you just put in your values and multiply. Oh, also the S, though, is going to cancel out. This S squared on the bottom is going to cancel out that. One of that is going to cancel out one of those, and we're going to get meters per second as our unit on the end.